ठीक है guys, let us start with topic 3.2. This topic is about this topic is about reflection and refraction of light. In the last topic we have already understood that light is a wave, right? And waves can reflect, refract, diffract, interfere and get polarized, right? Now with the example of light, we are going to see how does it reflect, what are some of the things that we need to remember about reflection, right? And we will look at laws of reflection. In the same way we will look about a few things with the law of refraction as well, right? So first thing, what is reflection? Reflection is when light bounces back. Okay, so the light that is coming to, see, this is a plane mirror for example. Okay, what does a plane mirror do? Mirror reflects light, and now we can see our face in the mirror, correct? So mirror reflects light. What is this? This is the incident light. What is happening? Light is being incident on a mirror. Now wherever this light touches the mirror, I can draw perpendicular line. This is known as normal. So क्या है? Normal. Meaning any surface, right? Let's say this is your incident ray. I should be able to draw normal here, right? Why is normal necessary? Because if the light passes through this normal, it reflects back in the same direction. That is what normal tells us. Okay, now this angle between the normal and the incident ray, what is this ray called? Incident ray, is known as angle of incidence, right? The first law of reflection is that angle of incidence is equal to, correct? So angle of incidence is equal to angle of reflection, and I can draw a reflected ray. But what is angle of incidence? Again, angle of incidence is the angle between the incident ray and the normal ray. What is it? It is the angle between incident ray and the normal ray, right? In the same way, I can draw a reflected ray where this angle becomes the angle of reflection. So this is how we draw the diagram. Okay, do you understand this? Do you want to draw this? What is this? Reflection of light. Angle of incidence is equal to angle of reflection. Let me know when you're done writing, guys.
We're done.
Okay. Now, if light is reflected, right, and it is reflected from almost every surface, no matter what happens, light is reflected from that surface, right? So, if you see that something is orange colored, right, so what light is being reflected from that shirt? Orange, right? If a shirt, or if let's say a wall is white colored, then all the light is being reflected from this wall. We see that leaves are green color, meaning leaves absorb all the other lights, but they reflect the green color, right? So, can we agree that everything reflects light? If everything does reflect light, can we also say, or can we also just notice that we are able to see our images only in a certain thing? For example, you may be able to see a faint image of yourself in the tiles, a faint image of yourself in this glass, faint image of yourself in that glass. But can you see even a faint image of yourself in this wall? What must be the reason? What is the logic over here? Yes?
It's opaque.
Everything is opaque, beta. This is also opaque, this is also opaque. If we ignore this and this, let's say the best reflector, plane mirror,
The light
is also opaque.
absorbed.
Okay, light gets absorbed, but if we have agreed that this is white in color, meaning it is reflecting almost all the light. Let's say it is absorbing some light, but it is reflecting enough light that we can see it. So it should be able to reflect enough light that we can also see our image. Makes sense that there is some fundamental difference where we can see our image and where we cannot see our image. What is this fundamental difference? This fundamental difference is the surface of things. Okay. So when I talk about glass, when I talk about tiles, when I talk about these kind of things, they are smooth surfaces. Smooth surfaces do not have a lot of irregularity in their surface, right? Like a plane mirror, it is plain. But what happens on a wall? It is a rough surface. It has a lot of jagged edges. Makes sense? When I look under microscope, this is what a wall would look like. And even you can feel it. Wall has a lot of irregularities in it. But if you look at a glass, if you look at tiles, it is a smooth surface. Makes sense? Pakku? खबर पड़ी कि smooth surface और अने rough surface. What is so different about their reflection that I cannot see my face in a rough surface, but I can see my face in a smooth surface? The reason is because surface is smooth, right? And the light that is coming from very far away, right? Its rays are always parallel. Light rays, when they are coming from very far away, they are almost always parallel. Now these parallel ray of light, do you know what is parallel ray?
Yeah.
Okay. When they get reflected, they stay parallel. Why? Because all of them have the same normal, which means all of them have the same angle of incidence. Because they have the same angle of incidence, they will have the same angle of reflection. And therefore, a parallel beam of light will stay parallel even after reflection. But what will happen with these surfaces? This surface will not have its normal which are parallel. Right? Because let's have a look like this. Let's say this is the surface, okay? If the light was incident over here, correct? What is a normal? Normal is perpendicular to the surface. So the normal will be somewhere, let's say like this. But if a parallel ray of light was incident here, because it is perpendicular to the surface, the normal for this light will be like this. So even if two rays of light that are parallel before reflection will become non-parallel, will become non-parallel after reflection, even if both the rays obey the law of reflection. Even if both the rays obey law of reflection, they will not remain parallel once they are reflected. Why? Because their normals are not parallel to each other. Makes sense? This type of reflection where they stay parallel is known as regular reflection. This type of reflection is irregular reflection. The importance of irregular reflection is that it lights up your room. Right? In this room, that there is a lot of light around. If only if the sun rays are coming on this wall, it will be like the whole room will be brighter. If this was only a regular reflecting surface, what will happen? Okay, sun rays ahiyathi avse and angle of incidence is equal to angle of reflection and aise chali jayegi. Right? Now, what will happen to the rest of the room? It will appear that there is light, but there will be a lot of corners which are very dark. But because once the light hits wall and then it goes everywhere, right? This actually illuminates the whole room. This is also known as diffused reflection. Okay? Do you want to write this down?
Yeah.
Please write it down.
So, what would happen in a circle-shaped object? How does that
Reflect?
Yeah.
I will show you. Note this down. Circular shaped object, if it is let's say polished, right? Then if it is polished, then its normal will not be parallel to each other, but it still has some logic to it. I'll show it to you, and I'll also tell you one of the use of those things. Okay. First note this down, then I'll tell you.
Done.
Done? Okay, let's answer Rudra's question. So he is asking what would happen if the surface itself was curved. So Rudra, let's take this is a curved surface, right? Okay, right? Now let's erase half of it, and this is not just curved in 2 dimension, right? What I'm like 2 dimension meaning, see, this is not just a circle cut. If it was a, let's say, football, right? If it was cut into half, it would be curved from every direction. It's not just curved in this direction, it is curved like this, right? In every direction. What would happen, right? Let's say that if I should have not. Okay, just a second, let me show some. See, if I zoom very much into this shape, do you agree that, let's say I want to draw a normal at this point. What will it be? It will be like this. Let's say I want to draw normal at this point. It will be something like this. All the normals of this curved surface will meet at a point. है ना? Won't it? If you imagine a circle, right? Then every radius, if there was a tangent, then radiuses are parallel to that tangent. So if I draw a small tangent here to draw a normal, then I'll have a lot of tangents, but all of these normals would pass through the center of this curved surface.
Yeah.
है ना? Now let's imagine a ray of light traveling from somewhere, right? Let's say it's traveling like this. Okay, this is your angle of incidence. So this will be your angle of reflection.
Oh, so light is coming from there to here.
Makes sense?
Yeah.
But if this is your angle of incidence, then the light comes back in the same path, because zero angle of incidence, zero angle of reflection. Right? I'll tell you where these are used. If this was a mirror, if this was a curved mirror, these are known as spherical mirror. Okay? Because the reflecting surface is inside a cave, right? This is an inside cave. This mirror is known as concave mirror. Okay? So, in older times, do you know there were mining helmets? Right now we don't need to use all of this, right? It was also used in cars. How? See, what you could do, you know that this is where all the rays are meeting, all the normals are meeting, right? So you can make this inside surface as a shiny mirror surface. Okay, you can cover it from here such that the inside surface becomes a shiny surface. Then you can place a bulb over here. Okay, what will happen? All of the lights, okay, all of the rays of light, let's say they travel like this, like this. This is the point where all the normals are meeting. But rays of light will travel and meet like this. This point for this mirror is known as focus. What can you do is, you can place a bulb at focus, right? And this can become your headlight. So your bulb is a point object, but somehow I have made a construction that the beam will be parallel. If the bulb was directly facing outside, what will happen? It will emit light in all the directions. But if I place a mirror over here, what will happen? It will emit a parallel beam of light, which can help in vehicles, which can help in. So, in mining, when there is underground mining, there might be very less light. So, they used lights on their helmet. And that contained, instead of light having a lot of voltage, which would take up a lot of energy, right? What they would do, they would place something like this, so that they have a parallel beam of light and they can focus the light at a certain place, right? They can face this side and there will be a parallel beam of light here, right? And can save energy also. right? If that was a reflecting surface, it would not be a regular reflection, so to say. Parallel beam of light will not remain parallel, right? If that is what you were trying to understand. Okay? Makes sense? Do you want to write this down? Let me know when done writing, guys.
Done.
Okay, so let us look at a simulation, right, to understand refraction of light. Okay, now this is reflection. Law of reflection is angle of incidence is equal to angle of reflection, right? There is one more law of reflection which states that angle of incidence, angle of reflection, and the ray of incidence, the ray of reflection, and the normal ray lie on the same plane. Meaning so that all of this is a two-dimensional process, right? It's not going to happen that the angle of incidence is like this, and after reflection it goes here. If gets reflected over here, it will travel somewhere like this. Okay, but it is not important for us to write now understand. It just means that reflection and refraction are two-dimensional phenomena. Okay, it does not change its path left or right. If it's going forward and downwards or upward, does not go left or right. Make sense, guys? Okay. હવે આ જોઈએ જો. What will happen? Let's say the light is going at 30 degrees, right? This should be our angle of incidence, है ना? And you already know from the chapter of waves what is refraction. What is refraction?
When light bends,
When light bends, bending of light when it passes through
one
medium
to another.
right? What should be the difference between these two mediums? The difference is that
Denser.
one of them has to be denser, right? Here the light is going from rarer to denser. How do I know that the light is going from rarer to denser? Because as we have seen in waves, this light is passing is shifting towards the normal. This dotted line is nothing but normal. What is happening? This ray is bending towards
Left hand side.
left,
Towards the normal.
right, which is towards the normal. So what do we say this about this in technical language? That the light shifts towards normal.
No.
Makes sense? Will you be able to remember this?
Yes.
What if the light was going from, let's say this was my glass and this was air, then what would happen to light? It will go
Away from.
away from normal because it is going from denser to rarer. है ना? Now just like the law of reflection, there is a law of refraction. Just before I do that, let me again go with air and let's say this is water. Okay, law of reflection, we also have law of refraction, right? The name of this law is Snell's law, but again we are not supposed to remember a lot of names. You just have to remember the logic. Sine of angle of incidence upon sine of angle of refraction is a fixed ratio, which is known as refractive index. So whenever light is going from rarer to denser, air to water, there will be a ratio of n, from where I can find out what will be the ratio of I and R. So let's suppose this diagram is telling me that the value of n is 33. Okay. So let's write over, 1.33, correct? Not 33, 1.33. Okay. What is the angle of incidence? The angle of incidence is 30 upon the sine of R should be equal to 1.33. Now, can we use a little bit of mathematics to find out what will be the value of R? Do you have calculators? I will make R the subject of formula. See, what you do is you will write sine 30 upon 1.33 is equal to sine R, and then you will write sine 30 upon 1.33, and sine inverse is nothing but the refracted angle. Tell me, what is it? Can you find it out?
0.37.
It will be in radians.
Oh,
That is not a calculator, that is a phone.
I forgot my calculator.
Phone does not follow BODMAS. Calculator does. So, Agata.
Syntax around.
First you find out sine 30 by 1.33.
Upon 133.
Which is?
S2D.
0.37.
Cannot be. See. It's in degree. Sine 30 bracket close divided by 1.33. Right? Then 50. But you have to write sine inverse beta. You have to. So shift sine inverse of answer is equal to 22.08. Now look at this image. If this is 30, this is 10, this is 20, and this is nearly 22. Right? So 22.08 is your answer. I can write 22 degrees is my angle of diffraction. Does this make sense? I can always use this ratio, right? Let's go back to the original formula. This is the law of refraction known as Snell's law, and this ratio is always maintained. Okay? Right? What if, should I erase this? Is it okay if I erase this?
Yeah.
Okay. What if I want to find out, let's say the light is, instead of light going from a rarer to denser, if the light was going from denser to rarer. Now we know that the sine of 22 is my angle of incidence and sine of 30 is my angle of refraction, and it is still true that the light goes away from normal when it is going from denser to rarer, right? The angle is increasing. What is this? Can you tell me? How much is this value?
0.75.
0.75. Now, see, I'll do a little bit of mathematics, okay? Sine I upon sine R was equal to n. But now because the light is going in opposite direction, should I be also able to say that here sine R is sine upon sine I is what I am trying to find? है ना? So should it be equal to 1 by n?
Yeah.
Let's find out the value of n is 1.33. Tell me if 1 by n is 0.75 something or not. Is it
1 divided by
1 upon 1.33? Is it? Okay. So are you understanding? When I take this as the incident angle, what happens to the refractive index? It becomes reciprocal of itself. है ना? So if I know one value, if I know refractive index for light going from air to water, I also know the refractive index for light going from water to
air.
है ना? Do I? Because it is just the reciprocal. Make sense? Pakka? Okay. So this is how you can work out a lot of refractive indices. Okay? There is a very long worksheet that we have, and in that worksheet we will understand all of these things. But right now, remember the formula. Sin I upon sin R is equal to n. If you have not written this down, please write this down. Now we are going to see something very new happening. Okay, let's say the light ray is going from water to air. Achha, by the way, this very faint light, right?
Reflection.
It is reflection. Some of it is always reflected. But right now, because we are interested in refraction, we are only going to look at refraction. Achha. Because it is going from denser to rarer, what is happening? It is moving away from normal. है ना? Now, will it keep on moving away from normal? If the angle of incidence increases, the angle of refraction also, right? It increases. Do I have an angle, right, over here, right, with this? Can I say that there will be an angle of refraction equals to 90 degree eventually? है ना? Because it went from 0, it went on increasing. Will I finally have at some angle of incidence? Will the angle of refraction be 90?
Yes.
है ना? Now, sin I upon sin R is equal to n. This is our formula, right? You remember this formula now? Okay. What is the angle of incidence? It is something. But what is the angle of refraction?
90.
है ना? It is 90. Now, there is a small thing we need to change. If n is the refractive index of air to water, I should have written 1 by n over here because it is from water to air. है ना? So the refractive index would be 1 by n. Make sense? Now, what is the value of sin 90?
1.
1. The value of sin 90 is 1. So can I write, if I reciprocate this, can I write 1 upon sin I is equal to n? है ना? I have taken reciprocal on both the sides because sin 90 is 1. Can I write 1 by sin I is equal to n? And an angle at which the angle of refraction becomes 90, the incident angle is called critical angle. What is the incident angle called?
Critical angle.
So that is a certain angle for which the light cannot go into the rarer medium anymore. It bends so much that it only passes through the plane of separation. Right? It only passes through the plane of separation. Right? So, can I write 1 upon sine? What is the name given to this incident angle? Critical angle. So, I will write 1 by sine C is equal to n. So, sometimes if refractive index is given, I can find a critical angle for which no light can go into the rarer medium anymore. Right? Makes sense? Do you want to write this formula? 1 upon sine c is equal to n.
Sir, I didn't get one thing. Sin I upon sin 90 is equal to 1 upon n. Only in water to air or any?
So diamond to air, glass to air, any medium to air will give you this ratio, because refractive index we generally take in respect to air or vacuum. Right? All the refractive indices we are going to study are given to you in the form where the light is going from vacuum to a certain medium and the speed of light in vacuum and air is equal. So you can say even from air to a certain medium. Okay? Done? Okay. Now see what will happen. You also need to understand this one. That see, wherever I go, there is some light reflected and some refracted. But as soon as I go beyond critical angle, right? Somewhere I will reach critical angle now suddenly, and then your refracted ray vanishes. Why? Because total internal reflection is taking place. See, understand all the words carefully. Reflection. The ray is reflected. The angle is so much that moving away from normal has made it to reflect back into the same medium. This can happen only in denser medium. In rarer medium, it is simple reflection. What is total? There is no light going anywhere. If the light intensity was 100 here, it will remain 100 over there. Right? When we saw refraction, some of light was reflected. But in total internal reflection, all the light gets reflected. Okay? Why internal? Because it is going from a denser medium into the denser medium again. Total, all of it internal back into the denser medium, and reflection because it is getting reflected. Does this make sense? This is sometimes abbreviated as TIR. Okay? Total internal reflection. But this is a topic extensively discussed again when we look at prisms. હમણાં શું યાદ રાખવાનું છે? હમણાં એટલું જ યાદ રાખવાનું છે that if the angle of incidence is greater than the critical angle, total internal reflection takes place. If angle of incidence is greater than angle of reflection, total internal reflection takes place.
Total
internal reflection takes place. And also I can show it with the help of waves that when refraction takes place, the wavelength decreases. See, clearly the wavelength is getting smaller a little bit, right? The more it bends, है ना? Is this making sense to you guys?
Sir, why is the ray getting bigger and bigger? The refracted.
No, they are just trying to show you that what will be refraction. It is still a ray. Its width does not change. Okay? Make sense, guys? Sure?
Yes.
Okay. Now there are just two last things left, and then topic for today is over. Okay. Now we already know that Sin I upon sin R is nothing but the refractive index. Now if you remember, can we write V is equal to F lambda? This is wave equation. This applies to every wave. है ना? Can I write that the speed of light in air is equal to frequency of that light into the wavelength of light in air? है ना? And speed of light in another medium, because it decreases, that is why it bends, right? So it will have a different speed, and clearly it has a different wavelength. So can I write lambda r, that is the refracted wavelength or wavelength after refraction, है ना? So can I find the ratio over here, that C, and we already remember that frequency does not change. Frequency only depends on source of the wave, है ना? So frequency cannot change. So can I write the velocity of light, the speed of light in vacuum or air divided by the speed of light in that particular medium is equal to the wavelength of light divided by wavelength of light in that medium or wavelength after refraction, है ना? Now what is this sin I upon sin R, right? If you draw a circle over here, right, and this is your center of the circle, right? I should change the color, just a second. Can I say this and this are going to be the radius of the circle?
Yeah.
है ना? And if I make a triangle like this, does this appear? What has happened? The angle of each of the triangles, so let's say this is theta 1 and this is theta 2. The angle of both the triangles are different to the normal, है ना? Now, if you remember, sine and cos and tan, all of them are ratios of angles and sides of a right angle triangle, right? Do you know this much? Now, without going into a lot of mathematics, right, simply that in this triangle and by this method they are actually trying to measure the ratio of the speed of light in different medium. So the refractive index is also equal to the speed of light in air divided by the speed of light in that particular medium. And if that equation is true, refractive index is also equal to the wavelength of light and wavelength of that wave after refraction, है ना? So we have, can I erase this much?
Yeah.
Okay. So what do we have? We have that refractive index is equal to sin I by sin R. It is also equal to 1 by sin C. It is also equal to the speed of light in air upon the speed of light in that medium. It is also equal to the wavelength upon the wavelength of light in that medium. Instead of R, I will write M. Is that okay?
Yeah.
Now, any two of them can be equated. For example, in a question they have given you refractive index and sin C, okay, or they have given you sin C and only, so you can find refractive index. Once you have refractive index, can you find the velocity of light in that medium? Or without finding velocity of light in that medium, if you have refractive index, can you find the wavelength of light in that medium? Now, if you have wavelength of light in that medium and the original wavelength, can you equate these two and find out the critical angle? Right? So, if you remember these equations, a lot of working will become easy. Okay? Please note this much down, and we are going to again discuss a lot about total internal reflection in the coming classes. Okay?
1 upon n is equal to sin C. No, if I 1 upon n.
No, n is equal to 1. 1 upon n is equal to sin c. Yes. Okay.